Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, as announced earlier, I will be continuing the data structures algorithm series with the help of Python. Today in this video, we are going to discuss about stacks. Now the agenda of this video is that we'll understand what are stacks. We'll understand some of the practical implementation, right? Right now, some practical applications that you can see, right? Day to day, we are using those things. We'll see that. And then we'll also try to implement it with the help of Python programming language. And as we go ahead, I'll also be covering the lot of interview questions that have actually come in the product-based companies, right? So let's go ahead and let's first of all go ahead with the definition. The definition is very simple in stacks. Stacks is an ordered collection of items where the addition and removal of the elements always take place at the same end. This is super important. And this end we basically say it as top end, okay, which we'll be discussing when we're discussing as we go ahead, So this is a simple definition of stacks. It is an ordered collection of items where the addition and the removal of the elements usually takes place at the same end. Now, usually stacks are represented by these two things. One is LIFO and one is FILO, right? Or we can basically say LIFO basically means last in, first out. FILO basically means first in, last out. That basically means the last element that is inserted into the stack will be the first element that we can remove it, right? So if I really want to show you, let's consider an example. Let's say this is a stack of books. Okay. Let's say I am just creating some stacks of books. Okay. So this is my book 1. This is my book 2, book 3, book 4, right? Book 5, book 6, right? Now in this particular case, when you are inserting the elements, this will be the first element that will be inserted. This will be the second element. This will be the third element, fourth, fifth, sixth, seventh element, right? Now, when you're inserting this, now suppose if you really want to remove, then you have to remove the topmost element. That is what last in, first out basically says. The last element which is inserted will be the first element that can be removed. Okay. So this element is basically called as the base element, and this element is basically called as the topmost element. Okay. And usually in stacks, this system actually works. Whenever you want to insert, and we also need to understand these key things because if you understand this components or attributes or methods, then only you'll be able to implement it. And the main thing with respect to stack is that you have to create some functions like push. Push basically means you will be able to insert the element, right? Pop basically means that you will be able to remove the topmost element. Okay, only topmost element. So in pop, you're just removing the topmost element. You're just not removing everything as such, because one after the other only will be able to remove it. So push and pop are one of the important things. There will be also one more function which is called as peek. Peek basically means I just want to see which is the topmost element. So in that specific case, you can basically implement peek also, right? You can also make sure that you can count the number of elements that is present inside this particular stack. Okay. And one more element you can basically, one more function that you can create is empty, just to check whether your stack is empty or not for inserting the elements. Okay. So you can also check this specific thing, right? Now, these are the basic function with respect to stack. I think many of you have used stack, but you also may be missing the practical application. So let's go ahead with the practical application, which is super important again. Okay. One of the practical application that I really want to talk about, and this I think many of you may be familiar with, and it may not be familiar with. Let me know whether you're familiar with this or not. Just write a comment saying that, Krish, I never knew about this, right? So you may be thinking where stacks is exactly used. Guys, I think everybody use browser, right? Now in browser, when you keep on serving pages in the same tab, you go and each and every page that you're serving, right? It will be stored in the history in the form of stacks, right? Stacks. So suppose let's say I am in www.google.com. Okay. So as soon as I see this, what will happen? This will get saved in the stack. Okay. Let's say from this, I was searching about some Amazon website, right? Then the second element that will get saved over here will be Amazon. Okay. Amazon. Then third, let's say I went probably to Instagram. Okay. Then this will also get saved in the stack. So as soon as I press back, right, then you'll be seeing that we will be moving towards this previous pages that we have visited. So an amazing application of stack is that it is definitely used in browsers. All the history information that you'll be seeing, right? You will be seeing that, with respect to this front and back tab, I'm not talking about the entire history, front and back tab. In the browser, you'll be able to see one front button and one back button, right? Like this one front button and one back button, right? So this is entirely saved in the form of stack. So as soon as you click on back, you'll basically be going towards the previous pages that you have visited. Okay. So this is just a small information about stacks. Now let's go ahead and quickly implement stacks. And again, the implementation will be quite simple, quite easy. First of all, as suggested, what all functions we are going to use, that all things we are going to use. So first of all, I'm just going to write class. I'm just going to create a class stack, and this class stack will inherit from the object. Okay, let's say. And then the first thing is that I will define my init method. Okay, init method, and here I'll be writing self. Okay, and then let's me create one simple thing which is called as items, and initially I will initialize an empty items, right? Items list. Then as suggested, first of all I will create an is empty function just to check whether the stack whether the stack is empty or not, whatever we are creating. So this will basically be returning, or I can basically write returns self dot items. Just a second. Self dot items is equal to blank. Okay, it is just going to return whether it is true or false, right? Whether we are just checking whether the items is empty or not. Okay, then the next function we will try to write push. Inside this we will give self comma item. Okay, and we'll try to implement each and everything with the help of this specific thing itself, because I really want to show you each and every data structures in object oriented manner itself, right? So when I'm pushing it, all I have to write is that I'll write self.items.append, and I will append with this specific item whatever I'm trying to insert. Then the next one is definitely pop. This pop is nothing but it is just going to remove the topmost element. Now, in order to get the topmost element, I'll just try it, something like I'll just say that return self dot items dot pop. So in list, you basically have a pop function, right? So you can basically use this list and you can implement all these things as you go ahead. Okay. Then the next function that you are probably going to implement is something called as peak. So definition, I'm just trying to see which is the topmost element. And you can create any more function. You can also create count function if you want. So I'm just going to return self dot items length of self dot items, and this will be -1, right? So that basically means you're just trying to get the topmost element. Now this is how you have basically created the stack in a quick way. Now let's go ahead and initialize it. So I'll say s of stack. Okay, and let's say if I want to push the element, so I'll write s dot push. Let's say I'm pushing one element. So if I probably want to see what is the element that I specifically have, then I can definitely check it out, something like this. So I can basically see s dot pick. So here you can see the first element is there. It is basically giving me the total elements. So sorry, the first topmost element that is basically inserted, right? I can also make sure that I can write one more definition, one more function, which will basically show me the size of the entire thing, or basically the count, right? So I can just write return of length, and this length will be length of self dot items. Okay, so this is just going to be return the length. So if I probably call this s dot size, you'll be able to now see, once I execute this s dot size, here you'll be able to see how many number of elements are there. Then again, I can push more elements if I want. Let's say I want to push 2, and if I probably see s dot size, again we'll be seeing the 2 elements. If I want to pop, so I can write s dot pop. So this will just remove, it is just giving the element which has got removed. That is what pop says. Okay, perfect. Then if I probably see now s dot size, it should be giving me the number of element as 1. Okay, so this was a simple implementation with respect to stacks. You can basically do push, pop, push, You can push any number of elements. You can push different elements also. So if I write a start push of 1, here also you can see h dot peak, you'll be able to see the topmost element will be 1, right? So you can definitely play with different things, and you can also use is empty just to check whether the stack is empty or not. Right now it is giving it as false, right? So this is how it needs to be implemented, and at one time you should be only able to see the topmost element, not the entire elements over there. And that is an important property with respect to stack. So I hope you have understood this video. I hope you were able to understand things. In the upcoming videos, we'll try to see about queues, and then we'll go with interview questions. There is some good amount of probability. So let's say around 2.5 to 5% of probability that you may get a question with respect to stacks and queues in the first round. And it is our duty that we'll try to understand all these things. So yes, I will see you all in the next video. Thank you, one and all. Please make sure that you subscribe to the channel. Bye-bye. Take care.